Let's see if Päivi Abernethy from Natural Resources Institute Finland can share her presentation on effects on climate change on fishing. And after that, Rainer Peltola will continue the same effects on climate change on foraging of non-timber forest products. But please, Päivi.
Yes, I am not very optimistic either, but let's try. So I am, this is a social scientific approach to looking at the climate change impacts on fishing, because there is an army of fish biologists that look at, but I'm a social scientist and have been working on the cumulative impacts on health and well-being of social ecological systems for quite a while now. And then the aspect is that as over the past 15 years, I've come to conclude that it is very depressing to tell to people about all the bad stuff. So I'll start with the bad stuff, and then I introduce a couple of not solutions, but approaches towards solutions. And the other thing I wanted to say before I go ahead is that I am a fresh import, now a year in Finland, but I've been the past 30 plus years outside of Finland and done most of my research in Canada. And so and some in Europe, in the UK and Germany, but so I'm talking about my work and examples I've been studying in Canada, actually. So going to the next so let's think about the climate change and its impacts on fishing. If there is no fish, there is no fishing. And in Finland, the discussion has primarily been on those temperatures and then the precipitation storms and various aspects of little or a lot of water. And in itself, it's dramatic and drastic enough for the fish. If we think about that 3 to 7 degrees, that the waters might be increasing, and that's the average in the year. And if we think about the last year in Finland, and how the water temperatures in lakes and rivers got pretty high during the summer, even up in the north. And just relating this to our human experiences, if people who like to sleep in the cold or feel it's unbearable when it's 24 degrees, and vice versa, people who like sleeping in the warm hate those couple of degrees lower temperatures. And we are mammals, but the fish live in the water 24/7. So the impacts that temperatures in and on themselves are influencing the fertility of the eggs, the morphology development, the growth. It's causing stress on the immune system, and so on and so forth. And then on top of that, all these different, the floodings or torrential rainfalls, the storm water from the roads and cities, and in the north, not so much that, but then all the stuff that is coming off the ground and industrial sites, when there is flooding, impacts the quality of the water. So there are several pressures just based on these two aspects. Oops, did this change? So in general, we think about fishing and climate change. We talk about these different aspects, like seasons are longer because of the warmer weathers. Number of fishing days is impacted usually by the bad weather and extreme weathers, but last summer I would say that it was the opposite. It was just sunny all the time. But the temperatures, as I talked previously, is affecting fish, and it's affecting fish differently. So the cold water fish of the Arctic will be suffering probably significantly more because there is no place to go. The warm water species are more okay with increasing temperatures, and probably, if they have a chance, moving up northwards. But there are also all these alien species and other diseases that we've been talking about already in this presentation today. There is a competition probably that is getting tougher, and also something that hasn't been talked much is the acidification of the water in connection with climate change. But in general, various cumulative factors in these social ecological systems that the fish live in, meaning it's the ecology and biology and environment that affects them as the nature, but it's also the human beings. And that complicates the situation. And it's that aspect that I actually want to focus a little bit more on and highlight here. Because climate change doesn't take place in vacuum. Even in up north in the Arctic regions, we know there are lakes that are not so much in Finland, but more to the east, lakes that are really polluted. We know that forestry impacts the waterways. We know that industry of other kinds, mining, impacts the waterways. And then there is these temperature changes and fishing, and that all are influencing the life. And I'm using salmon a little bit as an example because we have those salmon stock collapses taking place all over the world. And now we have the fishing ban up in the Arctic in Finland at Teno River. I just got back from the field research there last week, where we were studying the social impacts of that fishing ban. So if we look at just the direct and indirect climate impacts and not even any of this other social and other factors outside of that, we have this much larger influence on fish in the water. The spawning seasons are changing, and that creates problems in many ways. I'm pulling actually an ocean example, but it is the same thing in elsewhere, is that when the ocean waters, Pacific Ocean is right now 1 to 2 centigrades average warmer than it used to be, which is huge for an ocean. And there are kelp that likes to grow in a certain temperatures in a cooler waters, and that's where the herring is spawning. And that kelp is no longer growing in this further south, so it's moving northwards, and the fish is moving northwards at the same time. So where fish species are living is making a huge difference. And the same thing is the other factors that are influencing the warmer waters, as I talked about. I will talk a little bit more about the acidification from a perspective of complexities in measuring and monitoring. There are the toxic blooms and pathogens that we've been talking about a little bit. Algae growth in Finland has been significantly problematic in recent years. There are contaminant releases because temperature influences not just currents and the way the water moves around, but it also, if there is any kind of a older sedimentation of toxins, they can be released in the warmer temperatures. The flooding is influencing the contaminant release flow from the roadside, so the stormwater road. Ice cover being reduced for shorter periods in the wintertime is influencing the water temperature, but also impacts of precipitation and the evaporation. Water eutrophication is influenced the near bottom oxygen levels, and when you're thinking about the salmon, and here is the part where I wanted to tell about the less freshwater from Canadian context, is that the droughts in last years have caused some of the rivers where the salmon used to come up dry up so badly that they actually are just puddles, and so the salmon can't come up the rivers. And when you're thinking about when they get up the river and there's higher temperatures, the development of the eggs starts getting influenced, and acidification influences in the ways that I'm going to explain in the next. But it's not just how it's influencing the fish itself, but how it's influencing all the food and all the environment that the fish is used to growing or has adapted. So it's messing up with the whole entire concerted efforts of how the nature and the networks and the pathways and the feedback loops are working. So we are seeing significant changes in the ways in which climate change is influencing the entire water systems in the north, particularly. And the reason why I wanted to bring up acidification is that I presume people know that. Sorry, the reason why I'm bringing it up because it shows a complexity that we are not quite knowing how to handle. And I assume that most people are familiar with that because there's more carbon dioxide in the air, the equilibrium brings it to the water, plus there is the acidification from previous precipitations from acid rain and so on and so forth. And so we're having a problem with acidification in waterways. And there is study, again, in Canada, more in, for instance, different salmon species. And I took the pink salmon because that's the problematic salmon that has now arrived in Finnish areas, Finnish waters, and Tena River, is that they discovered, this is from 2015, that the early exposure to high levels of carbon dioxide during the early stages has significant impacts of the size and metabolism of the fish. And we know already now that over the past 100 years, but in particular in recent years, the fish, salmon particularly, has been studied, is becoming, for whatever reason, the fish are smaller that survive, that come up the rivers. And what is interesting and significant, that several salmon species, and there have been tests, I think coho salmon was another one in North America that was studied, is that it impacts their sense of smell. And this is detrimental in different ways, that they can't smell danger. So they're much more susceptible for any kind of predators, but also it impacts, they have an impaired sense of smell that prevents them from recognizing the specific amino acids that are associated with the streams where they are from. So they can't find back to the streams where they were born. And so this weight loss and impaired navigation and not sensing smell are just a few of the factors. And this is just what we know about acidification. Different species react differently. So this is just the studies we've made, that have been made, I haven't made, about the acidification impacts. Similarly, when we're studying the impacts in water, the climate change impacts on the water and connection to the fish is, in Nova Scotia, there was a study, government of Canada concluded that the acidifications of the waterways were actually killing salmon and significantly reducing the salmon stocks. And at the same time in Norway, there was a different study on the salmon in lakes, but that was pretty much based on modeling and some empirical studies. And they concluded that with the excessive rain, the acidification impacts would actually be reduced. And I'm not saying one or the other being wrong. I am stating the complexities of these modeling and assessment, which are incredibly important for us to trying to plan for the future. So they play an important role, but at the same time, they only give some indication. And one of the challenges that we are facing, as was previous speaker Berti was saying, is that we're now in a completely new situation where we don't quite know how old mechanisms work. And we need to start thinking innovatively in how to deal with new situations. And before I get to the solution part, I have one little gloom and doom picture as well. And this is from my, actually as far back as when I was doing my PhD in studying cumulative impacts and came in Wales and UK and Canada. This particular study was done 2013-14, but 2012 UK had massive torrential rains, and that led to, in Wales, to the historic silver mines flooding, meaning mines were already closed, a lot of them, but the tailings were overflowing, which led to lead flowing with the water downstream, and cattle downhill, not even at the bottom in the valley, but halfway, was starting to show some really funny behaviors, and some of them were dying. And the testing showed that they had 82 times, up to 82 times above the acceptable level of lead in their blood. And so this is an example that I just wanted to highlight, things that we don't even have in our modeling, things that we don't think about when we are thinking of the negative impacts of climate change on our fish and fishing in the future. So when we start looking at this, looking for new ways of dealing with the future, and this is stuff that I've been studying over the past good number of years, there is a different roles of local knowledge and the scientific modeling. And if we were combining those, we actually might be able to develop some alternative solutions of trying to protect our fishing and the fish and the lands and the nature and the biodiversity all together in the changing climate. And so I'm introducing this to here in Finland because I know this is not necessarily too familiar here. People are doing some citizen science, and I know SEIA and up in the Arctic, there have been some really good examples of this. But the idea here is that if we use the science that we have, and natural sciences and social sciences, and then we have local and regional practitioners and political decision makers at all levels, we have the local knowledge and indigenous knowledge together, we might be able to start developing solutions that actually work, because people who live locally, particularly hunters, anglers, fishers, I mean, farmers as well, they are down on the ground all the time, and they see the changes, and they can observe, and they know their land, they know where they've been doing their activities for the past many decades, and they have observed things, and they know how fish, for instance, usually behaves. So maybe working with them together with the scientific knowledge, we could start developing alternative models of dealing with the problems we have in the waterways, because that's the first area of reaction. We know from amphibians and fish that because they are there 24/7, they react faster than the mammals on the ground or the plants on the ground to any kind of particular changes that happen in the environment. They're much more vulnerable in their development and in their survival. And so, to keep things very short, this is from news from 2 days ago, actually. There is an indigenous peoples in Canada have started already 1990s, but monitoring things because they realized that the government wasn't able to have monitoring the same way. They didn't have the funding, and the people started collecting and documenting what they saw on the land. And this actually then evolved and adapted an idea from Australia, where they had the Rangers program, and the federal government 4 years ago, gave a pilot money, I think it was 25 million only at the time, to fund 20 programs to see if with the GIS mapping and the phones and the citizen science and particularly indigenous hunters and gatherers who were already there, they get some money to take pictures and document the location of the observations that they have. And some areas have developed it much further, but it had so good results that just this year, a couple of months ago, the federal government of Canada gave funding. I think this program now for the next stage has got 120. No, I'm not numbers, but several $100,000 to start looking into how this can be expanded and supporting the government and enforcing and monitoring and working together with them. And as an example of something that has been done in this kind of bringing the indigenous and local knowledge together to try to revitalize the rivers and to make them more resilient for the climate change, is this Hilchuk Nation's traditional style fishware in Koya River in BC. It's traditional fishing used in the modern context. And so the salmon or fish gets caught in this ware, and then the fishermen can actually pick the species that it's okay to use that are in abundance, and then let those that are in lesser abundance to pass. It doesn't harm the fish, and it is an effective way of bringing the modern science and traditional fishing together. And I know that in our studies at Tena River, we know that there were multiple Sami people who suggested that this might be able to use the similar kind of a practice to pick the pink salmon that is an invasive species and let the salmon that is suffering and in low in stocks to go through. And I believe Luke is also looking into that in the research model potentially. But so this is an example where we really can use a really ancient knowledge and adapt it to modern critical situation. And this doesn't mean that the science that we're already doing and the monitoring we're doing is not valid. It's just that these are complementing one another and making a situation stronger, in particular because monitoring climate change impacts is very costly, and it is we need a more systemic way of looking at things. So my last slide here is an example about taking it to the next level and maybe establishing some co-governance or collaborative models of actually working on the overall health of the rivers and the fishing and the fish and regulations. As from this is Cowichan Valley example, and then there is the Natama River Sami Co-Management Project that actually have both demonstrated very strongly positive results. And the most positive result in this is that when people are working together, we bring our different ideas and different knowledge systems and different ways of working. People feel like they are heard and their insights are taken into account, which reduces conflict in itself. It creates new innovative solutions, and it allows a better monitoring and better management practices on the ground because people feel ownership as being part of these solutions. So this was just my little short spiel on this. This is the stuff that I research and love researching. So it's not directly addressing the concerns of the climate change, but it is addressing the cumulative impacts and trying to find solutions within the realities that we live in. So that was that, and thank you.
Thank you, Päivi. And Rainer, we will continue. And some secret information. We have lost, unfortunately, our last speaker. I got the information early on, so that's why we still managed to keep the schedule and have lunch in time. But Rainer, your floor is yours, and we can have questions for Päivi and Rainer after Rainer's presentation.
Okay, thank you. So, from fishing to berry picking, the original topic was effects of climate change on non-timber forest products, and of course that's extremely wide topic. So I'm now focusing on bilberry. So this is the presentation is case bilberry, because I think that's the most most utilized non-timber forest product or natural product in Finland and also in Scandinavia. The yield formation of bilberry and of course all other berries and berry plants is quite complicated process, and it actually starts already in the previous growing season. So the full potential of next year's bilberry yield is actually forming, or it has already formed when the bud primordia form in the previous autumn. And of course the first step of this yield formation is the overwintering. The buds have to survive the winter time to produce flowers in the next spring. And what's crucial or quite important for this survival overwintering is the snow depth of the snow cover. And we know, based on remote sensing data, that the snow cover extent and duration has decreased in the northern hemisphere. You can see that in latitudes higher than 60 degrees, the average duration of frozen ground with snow cover was like 200 days back in 80s. And now it has decreased to 170, 180, and it is proposed to continue this decrease still. Of course, these numbers doesn't apply in Scandinavia and in Fennoscandia, because we have the Gulf Stream, which shortens our winter period. Anyway, especially bilberry is actually quite sensitive for frost damages and for successful overwintering. It almost requires snow cover. Of course, there has been a lot of winters without good snow cover, especially in southern Finland, so the bilberry is pretty much used to those winters as well. But it is quite obvious that if these frost damages due to poor snow cover are becoming prevalent, then bilberry coverage will decrease, and this gives competitive advantage for gramidodes, for weeds. And it has been proposed that bilberry coverage will remain in eastern and northern Finland, but it will decrease in southern Finland. So far we haven't seen much decrease of bilberry coverage due to climate change. We have seen quite dramatic decrease in bilberry coverage since 1950 up to 1985, but this is not connected to climate change. This is connected to change in forest management practices. But after 80s, we really haven't seen any changes in bilberry coverage, and inventory is going on right now. It is connected to Valtion metsäinventointi. What number is it, Pasi? 13. So after 1 or 2 years we will know whether there has been any changes in bilberry coverage, and if there has been any changes, then it's probably due to climate change. But the next phase of yield formation is the pollination, which is quite crucial for bilberry and also lingonberry and cloudberry and to almost all edible wild berries we have in Finland. And of course the conditions during the flowering determine quite much what is the pollination success. And we have the wildberry or forest berry monitoring network in Finland. You can see the network or the monitoring forests on the map on the left side of the picture, and this monitoring has been going on since 2001. And what we do in the monitoring forest is that we calculate the number of berry plant flowers, raw berries and ripe berries in 1 square meter observation squares. And here we have the 5 climate zones in Finland. The hemiboreal, south boreal, middle boreal, north boreal, and hemi-Arctic. And you can see in the picture the onset of bilberry flowering since 2001 in south boreal, middle boreal, and north boreal zones. There are no results. Well, there are results from hemiboreal zone, but the number of monitoring forests is so small that those results are not very reliable. Obviously, bilberry flowers later in northern parts of Finland, but what's important here in this picture is that there is no change in the onset of bilberry flowering. So the bilberry starts to flower about as early now as it started on 2001. No changes over there. But what has changed is the temperature conditions during the bilberry flowering. On the right side of you can see the graphs from south boreal, middle boreal, and north boreal zones, and the vertical parameter is the temperature sum during the bilberry flowering. It takes about two weeks for the bilberry flowering, and you can see that the average temperature sum during the bilberry flowering has increased. So we are probably seeing effects of climate change here. So the onset of flowering hasn't changed, but nowadays it's warmer during the bilberry flowering. And therefore what we see is actually an increase in pollination success of bilberry since 2001. And this is due to the fact that the pollinator insects are more active in warm conditions than in cold conditions. So this is actually a positive change. These results are not yet published, so they have not gone through peer reviewing, so please don't tweet about the results yet. And then, of course, after the pollination, when we have the raw berries, they have to get ripe berries, and climatic conditions or weather conditions affect also that process. For example, this year we had excellent pollination success for bilberry, but due to the extreme drought, the bilberry yield was not as good as we expected. What we know is that the mean precipitation is going to rise during the growing season by 5 to 11%, depending on climate change scenario. And of course, it's good for bilberry because bilberry requires at least some moisture and precipitation. But unfortunately, especially the fungal diseases can become more prevalent due to this rise of precipitation. For example, in Britain, there has been some reports that the Phytophthora kernovi has caused significant threats to bilberry. So this Phytophthora kernovi is closely related to potato blight, so it can have really devastating effect. So due to this direct rainfall and heavy humidity, there will be favorable conditions, for example, for Phytophthora. This is something that has been observed in Britain only, but of course we don't know what happens elsewhere. So some conclusions about the future of bilberry yields. There will be changes in snow depth, and it will change bilberry coverage. There will be changes, and there already have been changes in springtime and early summer temperature conditions that will affect the pollination success, and so far these changes have been actually positive. But we don't know about the future. If the onset of flowering, for example, become earlier, there is a possibility that there won't be enough pollinators for berry plants which flower earlier or in early summer or late spring. And of course, this increased precipitation is something that we don't know how much it will increase the pathogens, and especially fungi and molds, which require moist conditions. But if we want to mitigate these effects, practically only thing we can do is to make sure that the pollination populations are diverse and there are enough pollinators. And fortunately, there is a lot of at least discussion about this issue right now. Thank you.